Hello, welcome back to Beneficiary LiveNoding. In this episode, I'm gonna be showing you how to make spiral from scratch. So this is one example. Actually, Zefi is showing this example how to make spiral, and the notes is all there. But how he get there is actually quite interesting. If you actually learn a little bit of math, you know that one branch of math is probably a study of pattern using numbers. Um, so I'm just gonna open SVerchok, and a good way to study a number, there is one node that's doing that. Is actually number range. So this is the default number range, and by default, if you want to see the value, you use the stethoscope, and that's the value, but basically number between 0 and 10. It goes from 0 to 9, and you can adjust the step, and everything will adjust accordingly. There are a lot of ways to make number range. There's this one range, give you the start and stop and the stepping value. There is a count. I usually like to use this one because you can adjust the start and the beginning and the end, and you can adjust the number you want in between. There's also step, of course. Each one of them is powerful and useful. So with number range, and if you think of numbers, number itself is interesting as it is, but the pattern behind the number is actually what's, I think, more interesting if you're a visual kind of person. So if you have like a number range and you want to kind of graph it, maybe in the X and Y, you use vector in. So if you plug this in, X and Y, and you graph it, you graph the points. Yeah, you can use a viewer draw. So control click, this will create this viewer draw. You can see the graph. It's gonna go up like that, and if you adjust the number range, you can see how it's affecting the result. So this is the pattern that you get when using range, but you can change it to count, and you can adjust the start and stop. This is the one of my favorite. You can easily get a line that goes up and down, kind of more steep or less steep. And if you ever want to connect the dots, you just use the UV connections. So that's the basic idea. Set it to edges, so you have the vertices and edges. So, and you can control the count, of course. The count, in this case, if you want to make the line to be correct, you need to set the count to be the same. So that's really the basic idea of what I'm trying to explain to you. And we can eventually make this spiral, right? So the number itself is actually quite interesting, the pattern. If you, let me delete everything once again. If you use number range and you say you are using math formula, the one that's really interesting is, for example, modulo and integer division. So if you're ever kind of curious about numbers, you can always have range of numbers, and then you connect it into math formula or expression, or in this case it's called operators, I think. So modulo will give you a different kind of math pattern. By default, division by 1 give you 0, 0, 0, 0. Division by 5, however, give you the value that goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Right, that's the modulo. If you graph it, it's probably looking something like this. And then there's also integer divisions. If you division this by a number, for example 5, depending on whatever number range you are passing in, you're gonna get a value that's kind of this, doing this 0 0 0 0 5 times, and then 1 1 1, and then 2 2 2. So that's the pattern, and if you draw it, it's probably gonna be looking like this, kind of like a step, but it's kind of connected. So that's the basic idea. If you use factor in and you plug this number, you will see that this one is actually making a grid, which is I think pretty cool in itself. If I have a number like 0 to 10 and then make this 10 and make this 10, so I'm trying to make sense of what's actually going on. Modulo. Trying to figure out which one makes the most sense as a grid. Maybe start and stop 100. Step is 1. And we can then have a grid. Oh well, anyway, there's a pattern behind it. If we want to make a spiral, we can also use number range. So let's reset everything, and we're just gonna focus on the spiral. So number range. And how do we make a spiral? So we already know in the past, a sine wave looks like this, and there's a cosine that's kind of doing that. It's kind of like sine and being offset slightly. So that's basically the idea, and we can do that very easily. There's math operators in SVerchok that give you a sine and cos. Sine and cos. So if we have a number range here, and if we plug this in, we're gonna get the sine result and the cos result. And having sine and cos will give you a circle. Let's try here. So it's gonna create a circle. Let's actually graph this. And plug this in. So you can see, if I change this to count, if I make this between 0 and 1, or between 0 and certain some kind of numbers, 6.28 maybe, because it's like the value of pi, you're gonna get a circle, and it's gonna continue on and on as a circle. If you really want a spiral, you can then use something like a vector math and scaling, multiply scalar, and this actually kind of grow the points, right? But if we are using number range, kind of growing from small number to big number, we're gonna end up with a spiral. Okay, so that's the idea. See, this is like building a spiral from scratch, basically. Because you already know that SVerchok have a spiral nodes already, and this give a lot of options, and you can just connect the vertices and edges to get a result. Control click. So this is, of course, one of example. You can adjust interior, exterior. So you got everything already here with the nodes. And in fact, if you dig down into the nodes, into the code of these nodes, it gives you a lot of this spiral formula. But we're gonna make the one that's we built from scratch, and we're gonna try to resample it. So it's I think it's very interesting, and it's quite beautiful if you understand it. It's not always clear or easy, because I'm not like a mathematician myself. I'm an animator. I like to see the motions and kind of trace the motion and then figure out, okay, how to build that motion procedurally. Even that actually can be quite technical and confusing, but it's interesting to study. Okay, so we have control over the beginning and the end of this circle, and we haven't made this a spiral yet. Maybe if I plug this there, yeah, it's already starting to look like a spiral, of course. But we can also have another number range that simply connect there, so we can kind of control the spiral a little bit better. So the count probably need to be matching. And we can kind of grow it. So this control the strength of the spiral, the beginning and the end. This one control the actual spiral growth. And if you're happy with this, you can always use UV connections, and you get your spiral. Set it to edges, and you can bake it. Right, so this is a spiral, but on top of this, Zephy actually, he said resample spiral. In his version, he used this one, vector interpolations. So let's actually do that as well. Vector interpolation, what is this exactly? Select this one, not this one, that's different. Select this, connect this. So we are still only dealing with the vertices or points at this point, and you have this number, you have this interpolation value that goes from 0 to 1. If you update this, you can see you will see there's only 1 point, and you can actually use this for animations. So that's quite important there. But for our purpose, we need another number range. Set this one between 0 and 1. Plug this in. So now we are kind of resample the curve. So whatever we have back there, for example, if I set this a small number, we can interpolate that. So we have a lot of freedom here. So we are controlling the end and the start, and also how it interpolates. So let's see. So let's say your spiral is very low res like that. You can still control the interpolations. Okay, I think that makes a lot of sense now. So if you adjust this properly, so I have a feeling that maybe we can improve this. Yeah, so sometimes you actually want something like that, and I think that's can be quite beautiful. So maybe not too complex. So you start to get a kind of like a beautiful geometry. It's a math pattern, and you don't know at this point. You look at what you created, and then okay, so it's just using sine and cosine, and it's there's a scalar value that's growing those points, so you get this pattern, and you have a spiral, but it's only like a 2D spiral. How can you make it 3D? To make it 3D, of course, you want to expand these points, and I think there is one node. It's called a factory wire, and if you put a scalar number that's growing in the z-axis, you're gonna get a spiral that grows in 3D. So another number range, plug this in. In this case, you want to use maybe step, and the value is depending on this guy. So we do that. It's because we are already resampling the curve, right? Right. So there you go. That's what you get. And you just control the start and the stop. Okay, now we have something that's a little bit more beautiful. And then you can always bake it, and you have a line that goes spiraling and going up. But like I said again, we already have spiral nodes. But if you want to build it from scratch, you have all this, and I call this kind of node is like a power node, because it's already have everything. It hides all the complexity, and you only need to adjust the parameters or the attributes of the nodes, and you gotta get a result. This one is actually something that you build yourself, and if you build it like this, like the components, you can actually do a lot more. You can start to play around with more math formula, and all these operators can potentially give you some more interesting result. And check out the formula shape. This one gives you a lot of example of formula that can potentially adjust your creations here. All right, so again, yeah, it's one part of mathematics that's kind of interesting, and here we are using a lot of number range. So just remember that just simply by scaling or rewiring the numbers into the nodes, you're gonna end up with something that's interesting. Okay, so there you go. That's a quick look at a spiral, the making of spiral. Thanks to Zephy for this example. He actually made a lot of interesting setup. You just go to SVerchok GitHub, check what he's doing, and just grab the example blend. All right, like for example this one. So just for a bonus, if I get rid of everything, start from scratch, open up SVerchok, create a new node. So SVerchok have this GitHub loading. So SVerchok import and export. This is where you can actually send whatever node tree you have here into GitHub, and you can reload it. So if you have this link from Zephy, for example, this Corona cake, you right click on the GitHub link, and then you just simply get it from this link. As long as you have internet, you can get the result right away. So you can see his creations and how he created every step and procedure. At this point, it looks pretty complicated because it is kind of complicated. It's the formula that makes the pattern, and you will see a lot of maybe number range, math formula. You see a lot of numbers that you can adjust. It's I think it's quite beautiful. Even though you don't understand it, if you can visualize it, you can kind of say this is beautiful, and you can give a mark 100. Very good. Although not all pattern is easily converted back into math, but yeah, just have a look at it. Have a study. Just read it like maybe like a novel, like a book. Eventually, it might make sense, but even if it doesn't make sense, you can still adjust the parameters, right? You can still see what value is controlling what value, and the rest of them that you don't understand, you just call it magic. Okay, so that's the kind of, I think, very important concept for if you are learning about mathematics and computations. So yeah, that's how you look at it. I think hopefully this is useful. Let me know what you think, and I'll see you next time. Bye.